of Hallén.
Thank you very much. So I'm going to talk about refactoring, and I'm going to use PieChart as an example. And this is really going to be a beginner's talk. If you've done a lot of refactoring, I probably don't have a lot to teach you, but there might be some tidbits. So let's jump into things. I'm going to start by talking about some philosophy of refactoring. I'm going to bring up some tips and tricks for beginners, and then I'm going to show off some pretty graphs from PieChart, which is actually a really, really nice library. So the first principle, and here I'm jumping straight into the meat of refactoring. The first principle of refactoring is that if you don't have any tests, you are not refactoring. You are mucking about in your code and you're inserting new bugs. That is the most important thing I have to tell you. Refactoring is actually constrained work. When you are coding, normally, it's not constrained work, it's open-ended. You can come up with any sort of ideas for how to solve problems and things like that. But refactoring is sort of a thing like you're doing things in a factory. You decide what to do and then you do it. You decide what to do, then you do it again. So it's a manual process. It requires very little creativity. You decide on what the script is, then you follow the script, and you don't need to think all that much. You just need to be focused on getting the details right. And of course, if you're undisciplined, you're going to make a mess of it. So that's why refactoring can be hard. And again, no tests, no refactoring. Because if you're changing your code, you don't know if your refactoring has actually succeeded or if it has failed. So you work in a cycle, and that cycle is a little different depending on what sort of change you're making. If you're not making an interface change, an internal or external interface change, then the cycle is that you plan what sort of change you need to make, then you check your tests, make sure they're working, you modify the code, and then you check your tests again to see that they're still working. And since you have made no interface change, that actually means that you don't need to change your tests. And then, of course, your tests aren't working the first time, so you go through the cycle fixing bugs and then ensure your tests are working. And then you commit this to revision control. So you have one entity of change in your revision. If you're refactoring with an interface change, it becomes a little more complicated. Again, you plan what you want to make in the way of change. You ensure your tests are working. Then you change your tests. Then you ensure that they are failing, because you've made an interface change. So if they're not failing, then you have a problem with your tests. You know that. So then you modify your code, and then you go through the cycle of ensuring the tests are working again. The sort of refactorings you are doing is not something big and nebulous. It is actually something very, very concrete. And there are a couple of different views on how simple your changes should be. I'm taking a slightly higher level view. I think that you can actually manage to do changes which are not really, really atomic. But for instance, changing names, changing the name of a variable, changing the name of a class or a method, that is a refactoring. And names are important, so you should really, really make sure that your names reflect what your program is doing. If it doesn't, it's important to make such a refactoring. You can do changes like factoring out some functionality. You have a function which does two different things. Well, then you should separate those things. So you have two functions instead. Sometimes you've gone too far with this. So you have calls to getters and setters or something like that, which you don't really need. So you can do an inlining. Another very common thing is that you've developed your code for quite some time, and it's become a fairly big mess. So what you need to do is to modularize your code. You may need to turn part of your code into a class, or part of the code into a module, a package, or something like that. You may want to move functionality around. You may want to replace an algorithm. You may want to remove global state in order to make code re-entrant and things like that. And there is actually some literature about refactorings, and Martin Fowler is a person who's done quite a lot of this, and he has a list of refactorings which are not quite as high level as the one I've done here. I would say that he's more adapted to the Java world, where there are refactorings you never need to do in Python, because Java is a more primitive language. So moving on to PieChart. PieChart is quite a nice little library. It's made for making publishing quality graphs. And when I went around looking at different libraries, this was the one I thought looked nicest and had the simplest user interface, or simplest API to program against. It hasn't been changed since 2006, so it's probably abandonware. It's quite easy to work with, and it has a big variety of different output formats. So you can get PDFs, SVGs, PostScript, X11, PNG, and a couple of more formats as well. And you can get all sorts, various sorts of different graphs, which we're going to see examples of later. So why did I want to refactor this? Well, it has a non-Pythonic API. Almost all classes are called capital T. This is actually something that is common in other places. But what he's done is that he's made a package. So the identification of what things are is actually in the package name. And then inside the package, well, you already have the package name, so you can call your class T. But I don't like this. I think it's un-Pythonic. Then it has a number of places where it has a lot of nasty global state. I don't like that either. And then there are a couple of places where there is a mixing of concern, which we'll see later. So it's easy to work with, but in some places it is not as easy as I would like. For instance, when you have grouped bars in a chart, then you actually have to explicitly tell how many groups you want, and you need to say that, well, this is number one of 3 bits of data in each group. And that's not really necessary, so I want to factor that out. Another thing I want to do is to add a new output format. HTML5 is really nice. It has a canvas which you can draw on. And also I want to make the library embeddable. Right now there is a problem because the charts are actually generated as part of the exiting of the Python process. So here is an example of usage of the old version of the demos. So we do from PieChart import star. And that's not all that nice, especially if you're using this as your tests. And then you have these examples of area.t, barplot.t, etc. in the code. Category coordinations, coordinates.t. So how do I refactor this? Actually, this is what the code that we had before is generating. So we're setting up some defaults, and then we create an area which we are going to draw on. We add an x-axis with some format to it, and a y-axis with some format to it, and then we add 3 different bar plots. And here you can see that I have to say exactly where this cluster should be showing up. So that generates this graph, which I think is rather pretty. So I have some refactoring steps here. The first one is that I really need to make the imports explicit, because otherwise I have no control. I have no idea what I'm actually importing. And I actually want to be able to change a single one of these and not affect any of the others. So then I also want to turn these module imports into class imports. So instead of the from PieChart import area, I want from PieChart import capital area, which is the class import instead of the module import from up there. And in order to be able to do that, what I need is to take all the classes of the entire package and package them up in a new file called PieChart/PieChart.py, where I do all the imports. So I'm turning my entire package into a single module. That may be possible. I didn't actually look into it. This was something that was working for me, and it's quite explicit. Yeah. I'm not sure I know exactly how to do that, to be quite honest. So here's another example of types of charts you can draw. And then we're going back to our refactorings. So if we move back to this picture, when you want to fill one of these bars, you can actually specify both color and pattern for it. And that's called a fill style. And we were setting up fill styles in the old version, with going through a number of hoops, having a global under name table in this module, and then having another global called standards, which we were filling in. And this is quite messy code. We also had examples of all the colors which were set up like this, and then we ran functions in order to generate the colors. So I think I made something that was fairly much simpler. So I encapsulated all the colors and generated them in a list comprehension, and then I made the init simpler. I still need the global fills variable, because that is actually exported from the module. So that's where we store all the possible fill colors. So I've gotten rid of quite a lot of the global state that was there just in order to produce the list of colors. Here's another type of diagram that we can do with this package. It's called a rose plot. Another thing that we have as a problem here is that there is a series of classes in the old PieChart, one for each type of output that we're generating. So there's a PS canvas, a PNG canvas, PDF canvas, etc. And they render graphics in the desired format. So for PS, it does the PostScript rendering, and it also handles whatever the file-like object of the generated graphics that it's written to. And whenever you say about a class that it is doing A and B, that's a signal for refactoring. So in the new PieChart, I've refactored out the file handling. So it's now a separate class structure. And I thought I'd go off and show that. So I have a parent class file object, and then I'm specializing this for PDF files or for Ghost script and things like that. And we'll see here. So for Ghost script, it's actually going off and generating a command, a system command. And this was part of the generating class. And this is really messy stuff, which was entangled in the old code. So you get a much cleaner interface into the classes when you're doing these changes. Here's another example from the code. You can do quite neat things with zapping, both in the horizontal and in the vertical. Another thing that I really wonder what he was thinking of when he wrote this is that the actual generation of the charts is done by overriding the Python exit function, to include a call to the close methods of the canvases that we've seen here. And what this means is that you can't embed this program because you're relying on the actual call of the exit method. And it changes the exit method for you. So this is not very neat and nice at all. I haven't quite figured out exactly how to do this change yet, because this is still work in progress. But it is one of the things that is going to go. And I like the model where you're not really having to explicitly say, and by the way, generate things. But there has to be a nicer way to do this. We can, of course, generate pie charts with PieChart as well. Let's see here. And I should also show why I'm doing all this. Why am I not coming to the right page there? There. I started using this because I'm the member of a car cooperative, and I'm a member of the group in the car cooperative doing statistics. So we're actually keeping tab of how much the cars are being driven all the time, because if they aren't being driven all that much, we can't afford to keep them, so we have to sell the cars. So this is actually being used in a real life scenario. So this shows here, rather interesting, that in 2009 we had a downturn in the economy, and that actually shows that people were not driving as much on their vacation as they would be doing otherwise. Let's see here. There. So this is actually the gist of my talk. Refactoring requires test, and it requires very, very disciplined work. You decide on one bit, you go through it, you test it, make sure that it works, then you decide on the next bit, and you do that. The tests have to pass after every refactoring, because otherwise you're just mucking about.
You also need to test coverage.
Yes. Yes, of course you need good test coverage. Anything that you are modifying has to be covered by the tests. We
Did you use some special tool to make the refactoring, or did you just do it manually?
I have actually done all the refactoring manually. There are tools. I have tried to get them to work, but I have never managed to get tools to work. I think there is room for a really, really good refactoring tool, which actually looks at the entire, your entire source code, probably builds an abstract syntax tree, or maybe a concrete syntax tree of your code, and does the modifications to that. But I don't think there is one, a tool that actually does that today. And there is room for somebody to build such a tool.
I'm not sure what it does internally, but I did use Eclipse with PyDev. And PyDev, I think, internally used bicycle repairman. And you can do some stuff with it, maybe not everything, but at least such stuff as global search and replace function names or whatever. And I think this worked. But more complex stuff, maybe not. So
Yeah. Yeah. There is also a problem with the global search replace, because you're actually not sure where the name belongs, in which namespace, and that is why you actually should have a syntax tree that where you can actually detect that. But again, there is no such tool, and I would love for there to be one.
I read the difference manually after I used the tool, so I checked what it did and it looked okay.
Okay. All right, I'm going to open for questions and comments. Yeah.
A fair question, but if you have time and if it's not a bit too difficult, would you go through an example? Like, do a refactor for us?
I'm afraid I'm a very slow typist, so that's not really feasible. Yeah. Yeah. Yeah.
Did you develop the test? Well, I think we are still... Okay. You developed the tests by yourself? And the second question, related to the first, is how did you produce the tests, since the output is graphical? By comparing files? I don't know.
Actually, I did not develop the tests. The package comes with a very, very nice suite of demos. It's actually the ones you've seen in the presentation here. And so what I did was that I used the demos as my tests. They are pretty well covering all of the functionality, and you get all the different files, file types generated by the tests. So if we... No, I did that by hand. I actually looked at the outcome of all the graphs. You could do that, but I actually wanted to see when there was a difference exactly what the difference was. So I think it wouldn't have saved me any time to actually compute the picture difference. Yeah.
It was not quite a joke. You could really do this with Python imaging. It's rather easy to compute a picture difference. It's just 3 lines of code also.
Yeah. So this is the suite of demos that I've been using. It actually has quite a few very, very neat things that it can do. In this one, it's got error bars in it. Oops, there. And of course you can do horizontal bars and things like that. That's a neat one. You can actually do clipping in the package. And you have a number of different things you can do. And you can really, really neatly add different axes. There is an example where you have double x-axis, which comes a little later. Let's see here. We have scatter plots as well, and you can draw bars and diagrams. Let's see where we had that one. Oh well. Laura?
Hi, I just wanted to say something. I'm a an Emacs user and have been doing refactoring by writing my own list macros for a long time, and I thought, I will never change, I will never change. Besides, I've got my lifetime invested in Emacs. And yesterday I was talking to the PyCharm people, and they have a refactoring mode for their PyCharm IDE, which I hadn't seen, and they were faster at it than I was. So I am seriously thinking of going home and getting out PyCharm and seeing if I can stand the rest of it, because it seemed to be making the refactoring going easier. So when people are looking for a way to do it, PyCharm is that. And the other thing is they're really, really interested in finding out what it is that people need for refactoring. So we could get in on the ground floor and say, this is what we want, please make us one of these. So I thought that since people are interested in that, we should probably talk to the PyCharm people.
Okay. Sorry? Yeah. What was it?
I have a perspective from managing teams of developers, maybe with quite a few developers in. If ever you find yourself in a situation of trying to decide who to ask to do refactoring, it's worth noting from my experience that some people are brilliant at it and love it, and some people not either dislike it and tend to be bad at it. It really is a very, very polarized skill, and it's really worth making sure you've got someone that's going to like it. Some people thrive on the attention to detail and the sense of closure of statistically making it better, and other people just cannot find any motivation for it at all.
I think that's a very, very useful comment. Personally, I enjoy doing refactoring. I have actually taken a number of people's code and done rather large refactorings to them. And you discover many, many modes of error that beginners are doing. One thing I did was for the Royal Library in Sweden, where I did a refactoring of a package for a server called Z39.50, which is a standardized way of accessing library data. And the one who had coded that had a coding style where you would call a function, and that function would call a function, which would call a function, which would call a function, nested to a level of about 7. And I refactored that, so I had a function that called function A, function B, function C, and then I was done. And this was a very, very large refactoring. It took me about 2 months, but it brought the size of the code from about 3,000 lines to 600. But that was C code, so it's not really relevant here. Okay, yeah. Yes. There was actually a time in the late 60s, early 70s when IBM paid their programmers per line of code, and it showed. I think there was almost a tenfold increase in productivity. Yes. Mm-hmm. Okay. Any more? Yeah.
From what I understand, the refactoring is not complete of the PyCharm. So do you plan on any sprints during the weekend or something like that?
I actually haven't planned any sprints, but if there are any people who would be interested in joining, then I would be happy to do hacking on PyChart during the weekend.
So once the refactoring is complete, will you publish the changes as a fork for PieChart, or publish a new version or something?
I plan to do some sort of publishing of a new version, and I haven't tried to contact the original author yet, but my guess is that it will be published as PieChart 2. I've discussed with a few people, with Guido for instance, what would be the best and most polite way of doing this. And of course, since it is a total change of the user interface, it shouldn't just be called PieChart or with a new version number or something like that. It has to have a new name. And I think PieChart 2 is probably the right name to go for.
You said at the beginning that refactoring is a task that requires less creativity respect to development. I'm not so sure about this statement. I think that refactoring sometimes requires so much imagination on how to re-implement or the logic that it was necessary for me to proceed by different steps. So spend more time because I couldn't imagine at the first time how to refactor properly or the contents. So it requires a lot of imagination for me and also for creativity, but in a bounded context. That's true. So this was an observation. And a question. You said that it is quite a manual task, but this means that it becomes easier for you to forecast how much time will require a specific change, and you can respect these forecasts with a good precision or not.
First, I would like to comment on your comment, and that is that you're absolutely right. There is a step which requires creativity, and that is the step where you're deciding what refactoring to do, because that requires you to imagine what the code will look like after you make a change. So you have to sort of imagine different scenarios. If I do this change, what will the code overall look like? You're not imagining specifics, but you're imagining what the structure will be, and will it be smaller, will it be neater, etc. The second, yes, once you've decided on a specific refactoring, it's very easy to work out how long time it will take, because usually you can do a grep to say, see the places you need to change. And if you need to change 100 places, and each place takes a minute, then you have 100 minutes. Laura?
That just reminded me of something. I guess 30 years ago, I was teaching at the University of Toronto, teaching undergraduates. And we had some undergraduates who could refactor really well, and we had some undergraduates who were really, really, really lousy at it. And so we did a bunch of things to try and figure out what we could do to train the people who were rotten at it to get better, and we found out by accident what it was. The accident was that an extremely beautiful blonde girl who gave courses in sketching and drawing and how to draw shapes and things like this. And by chance, half of the people in my tutorial group thought she was absolutely drop-dead gorgeous, and they would go take a class in absolutely anything she was teaching in the afternoon. And the ones who went off and took the course in sketching got a lot better at refactoring than the ones who didn't. So I thought that was very odd. So the next year we were going off and did this, and I split the class, and I had them take a sketching class from someone who wasn't gorgeous, and to see, to see whether being with gorgeous people makes you refactor better. That would be an interesting conclusion. But no, learning how to draw makes you refactor better. If you're rotten at it, take a drawing class.
I can't draw, but I still think I'm good at refactoring.
Oh, no. It doesn't work the other way. There are people who are good at refactoring, and they're still rotten at drawing.
W-
the people who took the drawing class got better at refactoring,
Yeah.
which is not what we expected.
I think I can give an explanation for that, and that is, yes. When you learn how to draw, you learn how to picture what is going to be on your paper before it's there. That is exactly what you need to do when you're refactoring. You need to picture what this will look like after you've done the change. It is sort of the same in development, but you are more constrained when you're drawing, unless you're doing abstract drawing, and when you are doing refactoring, because you have a model that you're starting with. You have the real world when you're drawing, you have the existing code when you're coding. So you have constraints that have to be transformed into something that you are producing. So that's a difference. Okay. That seems to be it. Thank you all for coming. I hope you learned something here. Thank you. Bye-bye.